basically a transformation is you're just moving things around. You're taking the same, you're taking a function, a base function, and you're moving it around. You might be stretching it or shrinking it or any of that stuff, but that's what we're kind of talking about. So the identity function, we're just kind of going over some basic functions here. The identity function, y equals x, wants to talk about what the domain is. And remember, the domain has to do with x. And this basically gets bigger and bigger and bigger. And if you can answer that question that it's going to get wider and wider and wider, then the answer is that the domain is all real numbers. Okay, sometimes I'm not going to write this every single time, but there's some other ways to do this, right? You could say all x's such that x is a real number. Okay, that's another way to write this. Another way to write this is everything from negative infinity to positive infinity. You guys have seen some of those by now. Range is talking about the y values. And when I'm talking about y, I always start at the bottom and go up. And so you can imagine that this line is going to keep going down forever, and it's going to keep kind of going up forever. So it's going to be the same thing. Okay. I'm not going to write all three of these every time, but if we're talking about real numbers, that's what that looks like. And I did something wrong. Did y'all catch my mistake? Talking about y's here, not x's, because we're talking about range. So this should be all y's such that y is a real number. Okay. What about this y equals x squared? Can you imagine that it's just going to keep getting ever so much wider? Okay, so it's going to end up being the all real numbers thing, because it's going to, that u is going to keep spreading wider and wider and wider. Okay, when we talk about the range though, what the y's can be, and we start at the bottom and we go up, it kind of looks to me like there is nothing on the graph below this line. And what is y equal to right here? Y is equal to 0. So it's okay if it's 0, right? But it has to be bigger than 0. So we would write, there's two different ways we would write that, right? We could say all y's such that y is bigger or equal to 0. Or we could say, we would want to put a bracket here, not a parentheses, because it could be equal to 0 and go to infinity. Two different ways of saying the same thing. Okay, what about this one? We talked about this for just a little bit. If you try to type in your calculator the square root of a -1, it's going to say imaginary or something like that. Right? You can't take the square root of a negative number. So on this one, this square root of x can't be smaller than 0. And you can tell that by the graph. Look at the graph. Does this thing keep getting wider and wider and wider? Well, it does this way, but it doesn't this way, right? So if you look at this graph, the first time that we have anything is actually right here. So our domain could write as all x's such that x is greater than or equal to 0. Or you could say, keep doing that wrong. Or you could say it's 0 to infinity. Because you can't take the square root of a negative number, so it can't be. That's why you're not getting the negatives down here. When we look at range, you want to start at the bottom and you want to go up. And so when I'm looking at the bottom and I'm headed this way, the first time I see a value for anything is right here, the same point, and y is equal to 0 right there. So we would say something similar. All y's such that y is greater than or equal to 0. Now, so I didn't say this, but this could be kind of confusing. Is this going to go up forever? So the bigger that X gets, the bigger Y gets. Is that always going to be true? Because it kind of looks like it kind of looks like it comes out here and then it kind of flattens out. So what I know it doesn't, it gets bigger slower. I kind of made that go up too much, but it gets bigger slower. But I mean, if you kind of pretend you can plug in some numbers for X, and if you plugged in the square root of 1,000, and then you plugged in the square root of 10,000, well, the bigger the X is that you plug in, the bigger the Y is going to be. Okay, so yeah, it's going to go up forever. Do y'all agree with that? Okay, so it is all Y's that are greater than 0. Okay, what about this one? That Y is equal to X to the third. Okay, so on the domain, you want to ask yourself, does this keep getting wider and wider? Is there a number that I'm not going to be able to plug in for X? Because domain is talking about X. You can plug in any number for X, right? So it is going to keep getting wider and wider, even though it kind of appears like it levels off. It gets wider slower, right? But it's still going to keep getting wider and wider. So your domain would be all real numbers. And you know, I'm not going to keep writing this, but you can write that 3 different ways. Right? Okay, what about the range? If we start from the bottom and go up, what do we have? Well, it's going to keep going down forever, and it's going to keep going up forever. So the range would also be all real numbers. Okay, what about this one? Can you take the square root of a negative number? I mean the cube root, sorry. Can you take the cube root of a negative number? Can I do the cube root of -8? The cube root, remember, is asking you what number times itself can you multiply 3 times to get -8? Because we couldn't take the square root of a negative number, it was imaginary, right? But if you, but -2 times -2 times -2 is -8, right? Yeah. So that's the answer. So yeah, you can take the cube root of a negative number. It's not a problem when it's the cube root. It's only a problem when it's the square root. Is this, I mean, look at the graph. Is it going to get wider and wider? This goes forever this way. This goes forever this way. Okay, what about if you go look at the Y's and you start at the bottom and go up? Is this going to keep going just a little bit farther down forever? And this is going to keep going just a little bit more up forever? That's going to be all real numbers. Okay, it never completely levels off there. Is everybody okay with that? Okay, this one you already know has a problem, right? 1 over X. You can see it in the graph when you look right here at the X-axis. There's a split right there in the graph when you look at the X-axis. So that means that there's a problem when X is equal to what? The denominator can't be equal to 0. So the best way to write that one is all X's such that X is a real number and X is not 0. Okay, is there going to be anything that the range can't be? Look at it the same way. It looks like there's a problem right here. It's like there's something going on with the graph. On the y-axis, it looks like there's another split. Do y'all see that? Looks like there's might be a problem at 0. So you're going to kind of think in yourself, is there any way that I could solve this problem where I'm going to get 0 for an answer? Is there anything I can plug in there for X that'll give me 0 for Y? No, right? There's nothing. There's nothing that's going to, because you put a 0 in there, you can't. So there's not going to be anything. So this one actually is all Y's such that Y is a real number and Y is not 0. There's a split right there in the graph. This one is an absolute value function. It gets wider and wider, so the domain is all real numbers. It looks to me like the range when you start at the bottom and you go up. I mean, the whole point of an absolute value is that it makes the answer positive, right? So you don't have any values for y until you get right here. So we have a couple of ways to say that. We can say y, all y's such that y is real and y is, you don't have to say it that way, sorry. You can just put all y's such that y is greater than or equal to 0. Okay, or you could say 0 to infinity is allowed. It could be equal to 0, so it gets the bracket to infinity. Questions about any of that stuff? So these are kind of base, these are base functions. These are what we're going to be moving around when we get to the next page. So this kind of, we're going to come back to this in just a minute, but this kind of gives you some cheats when you're doing your homework and you're trying to figure out what's going on. So the first one says, basically, if you take a function and you add something to it, you're going to go up. If you take a function and you subtract something, you're going down. Okay, this one is a little bit different because it's inside the parentheses, but if you're subtracting, you go right, which is opposite of what you would think. Because usually you would think if you're going to subtract something, you would go left. And if you're going to add something, you go left, okay? If they put a negative in front of the function, they're reflecting it across the x-axis. And this is really kind of hard to explain mathematically with this part, but if they're plugging in a negative, then you're going to reflect it across the y-axis. If you multiply the number in front by something that is big, or you multiply your function by something that is bigger than 1, you're stretching it vertically. If you multiply your function by something that's between 0 and 1, a fraction, right? Between 0 and 1, you'll be shrinking it. And then if you multiply whatever number you're plugging into your function, and this one's really tricky without looking at an example, which we'll do in a minute, you're talking about horizontally shrinking or stretching it. Okay, so when you start, this is kind of a cheat sheet we'll come back to as we're going over the examples. So here's our first one. They're wanting us to say that the base function is y equals 1/5 x to the 4th. So the black that is drawn right here is your base function. Okay, so to get from the black to the red, it looks like they've done what? Shifted it which way? Up, right? We've gone to get from the black to the red. It really looks like we've just shifted it up, and this is 5 right here. We're not changing anything else. So we are shifting it up 5. And that's why, look at the equation, that makes sense. So it's 1/5 x to the 4th plus 5 because they moved it up 5. If you're adding something onto the function, you're shifting it up. If you're subtracting something from the function, you're shifting it down, right? So the translation is because we are moving it, I'm just going to put up 5. So on this one, our base function, the one they started with, is y equals 1/5 x to the 4th. And then we've got this kind of teal looking color. So how did they get from the black to this one down here? Did they go up or down? They went down by how many? 3. And you can see that in the equation because it says 1/5 x minus x to the 4th minus 3. So we're shifting it down. So if you add something to the function, it's going up. Subtract something, it's going down. That's pretty easy to kind of take in. This is the one that's, this next one is the one that's opposite of what you think. So they're starting out with 1/5 x to the 4th. They're ending up with 1/5 and then times in parentheses, x minus 3 to the fourth. So this one's different because the minus 3 is inside the parentheses. Okay, when it's inside the parentheses, you're talking about going left or right, and it's opposite of what you think. So you can tell here that if we're going from the black to the red, that we're actually moving something to the right 3. And in my mind, that should be a plus. Do y'all agree with that? So that one's in your mind. You're going to have to tell yourself, okay, when we're going left or right, the equation is opposite of what we think is supposed to happen. Okay, so if it's inside the parentheses, it's left or right, and you need to think opposite of what I think. So on this one, our base function is y equals 1/5 to the 1/5 times x to the fourth. And our translation is 1/5 times x plus 7 to the fourth. That makes me think a plus 7 makes me think, I know it's inside the parentheses, so it has to be left or right. But I know in my brain, I'm like, well, plus 7, that should be right. But I know that we said, okay, this one's the opposite of what we think, and we're actually going back to the left 7. So you don't have to write this down. If I write down y is equal to x plus 4, what would your base function be? Okay. It would just be the regular old plain old x, okay? So your base function would be y equals x. What does the plus 4 tell us to do to that base function? Up 4, because the plus 4 is not included in any parentheses. It's just up 4. If I had it written down y equals x minus 4, you would say down 4, right? If I write y equals, I changed it now, right? So it is, the plus 4 is in parentheses. We're not talking about up or down anymore. We're talking about left or right. And you would think it would be right would be plus, but it's always the opposite what you think. So this is shifting it to the left 4. Y is equal to. Okay, my base function here is just y equals x. What does the plus 2 on the outside of the parentheses tell me to do? Up 2. What does the minus 3 tell me to do? Right 3. Y'all good? Because if you don't get these two, it's hard to move on. Okay, you need to know up and down and left and right before we add anything else. Okay. So this one's not too bad. This says, the top one said, so the graph of y equals, and then if you put a negative in front of the function, it's the reflection of the graph across the x-axis. If you make the x negative, it's a reflection across the y-axis. So let's talk about what that means. If you compare these two functions, your y equals 1/5 x to the fourth, and y equals negative 1/5 x to the fourth. Okay, you can see that the only difference is they've added a negative in front on the one that is in red. So all this is a reflection across the x-axis, because that's the only difference. We've added a negative. Okay, this one, I'm going to write this just a little bit bigger. I know you can maybe see it on your paper, but also know your paper is in black and white, and it might not have copied super great. So this is what this says. Okay. So look at those two functions. How are they related, or what's the relationship between them? Not on the graph. Well, you can see it's reflected across the y-axis, right? You've got a filled in line and a dotted line. And if you folded that on the y-axis, they would land on top of each other, okay? But look at your equations. How are those related? If this is negative x to the third, if you look at the other one, it's the opposite of that. It's positive x to the third, right? This one's positive 2x squared. The other one is negative 2x squared. So that's what mathematically this thing does when we plug in a negative x and reflect it across the y-axis. We're looking for equations that are exactly opposite of each other. Okay, so you don't have to write this down. I'm just trying to make sure you can wrap your mind around this stuff. So if I say y equals x squared minus 4, you're going to tell me that the base function of that would be y equals x squared. Okay, what does the minus 4 do? Down 4, right? Down 4. What if I said y equals? Okay, you're going to tell me that this plus 4 does what? This plus 4.
Oh, that plus 4 goes up.
Up 4 because it's on the outside of the parentheses. This 2, because it's opposite of what we think. We would think plus 2 would be to the right. It's on the inside. So yes, left 2. We're doing with that one. Okay, reflection across the x-axis. This one's kind of tricky because they are exactly opposite. But yes, because we just put the negative in the front. We didn't have a whole equation that we were talking about. If I started with, let me give you another example of this one. We say y equals 2x plus 4, and then we end up getting y is equal to negative 2x minus 4. They went exactly opposite of each other. Okay. So this one is a reflection across the x-axis. We're just flipping it upside down. Everybody okay with that stuff? Okay, let's move on. To me, this is the most confusing. And I don't know if it's because mentally in my mind, I just have trouble seeing the stretching and the shrinking and the stuff. I have to kind of pretend like it's fat people and skinny people, which makes me feel bad. So, I mean, you stretch or shrink things, you know. So this says the graph of y equals a times f of x can be obtained from the graph of y equals f of x. You are stretching something vertically. If this a right here in front of your function is bigger than 1, if the absolute value of it is bigger than 1, so that means it could be negative, and when you take the absolute value, it becomes positive, right? So we're looking for things that are bigger than 1. It is shrinking vertically if the number in front of your function is between 0 and 1. And that would be things that are like decimals or fractions, right? Okay, so our original they're telling us that this is our original function. This says y equals x to the third minus x. I'm a little worried that you guys might not be able to read that on your paper. X to the third minus x. So this number, the only thing that's different between these two is the green, or the one that's shaded in, has a 2 in front of it. Well, the absolute value of 2 is bigger than 1, right? So that means that we must be stretching it vertically, which is what this is. Okay, if you compare these two, y equals x to the third minus x, and this one's y equals 1/10 x to the third minus x. Well, 1/10 is the only thing that's different between these two. We're multiplying this whole function by something. So that is between 0 and 1 if we take the absolute value. So we are shrinking it vertically. Okay with that? And so stretching something makes it skinnier to me, because you're like stretching it out. My daughter is 5, my oldest daughter is 5'9", and when she was in high school, I was like, you're going to appreciate this later because you can eat more. You know, like if you're taller, you can stay skinnier better because you've got more room to stretch, right? So stretching something is going to make it skinnier. Shrinking something is going to make it fatter, right? More squished. Okay. Y equals x to the third minus x. Same function that we've been talking about. And then this one up here says y equals -2 x to the third minus x. Okay, so looks like to me we got a couple of things going on. The number that we're actually multiplying by is 2. That number is between 0 and, is bigger than 1, sorry. The 2 is definitely bigger than 1. So we're stretching something vertically, which is what this says. What did the negative make it happen? It reflected it across the x-axis, which was, and you can see that that's what happened here. I think it's very difficult to kind of see the stretching part, but it's not difficult to see the reflection. Okay. How are you guys doing with this so far? We're almost done. We've got one more little section to add. So I'm going to kind of recap just a little bit. So what if I have y is equal to -3? Let's say our base function is y equals, we'll just make it easy on ourselves. Our base function is y equals, y'all don't have to write this down, y equals x. Okay, what does the 3 is definite, we're multiplying it by, let's ignore the negative. The 3 is bigger than 1, so we are stretching. And the negative part is going to make it reflect across the x-axis. Okay, so let me back up. Let's make this a little bit more challenging. Okay, the -3 is inside the parentheses, so we're going left or right. Right 3 1/10 is being multiplied, so we're talking about this function right here. Multiplied by 1/10, so it is shrinking because that number is less than 1, between 0 and 1, right? Are y'all okay with that? Kind of catching on with that. So this is on 2 different pages, but the graph of y equals f, and they're multiplying inside the parentheses, they're multiplying the x by something. That's when you're going to shrink it horizontally if it's greater than 1, which is backwards of what you would think. You'd think if you multiply by something, you'd be stretching it. Well, this one's also one that's backwards, and if it's between 0 and 1, you're stretching it. So if you're multiplying it by a fraction, you're stretching it horizontally. Okay, so this one, we're using the same thing, y equals x to the third minus x. We're changing it to y equals, I'm gonna put this a little bit higher so y'all can see better. Y equals 2x to the third minus 2x. So that, do you see that inside the parentheses, we've added a 2? Okay, so that's different than multiplying the whole function by 2. So now, because it's inside the parentheses, we're talking about stretching or shrinking things horizontally. And it's backwards from what you think, just like the other thing that was inside the parentheses. Remember, if it was, we added or subtracted inside the parentheses, we went left or right, opposite of what we think. So if this is inside the parentheses, the 2, I would think it would make it stretch, but it doesn't. It makes it shrink. Okay, this one is multiplying by, this one's y equals 1/2 x to the third. Well, to me, if I'm multiplying it by half, that would make it shrink, but it makes it stretch. Okay, and then this one, when they added the negative, what happened there? Reflected, yeah. So we've multiplied by 1/2, which made it a stretch horizontally, and then we've reflected it. Okay, so if you got that, that's pretty much it. So we've got a few little examples down here we're going to talk about. It says determine the basic graph involved and then describe in words how the graph of the function can be obtained from the basic graph. So on this one, our basic graph would just be, I'll use the language that they're using. F of X is equal to the absolute value of X. So what does the +2 do to that? Shift up 2, right? Okay. This one, the basic function would just be X squared. Okay, we're kind of stripping everything away from the X except for, so all the other numbers get shifted away from the X when you look at your base function. Okay. I see a -5 inside the parentheses. So that means left or right, it's opposite of what you think. Y'all are so smart because I hear a whole bunch of right 5. Okay, this one is F of X equals the square root of X. We're subtracting 4. Down 4. Okay, given the equation for the transformed graph, I did not read that correctly. Sorry. Give the equation for the transformed graph. We're starting with y equals the square root of X. We want to shift it to the left 7 and down 5. So when you have a square root, whatever is underneath the parentheses is, or whatever is underneath your square root is kind of considered in your parentheses. That one's kind of tricky. So I'm going left 7 +7. Everybody okay with that? Down 5. Yep. So we're starting out with y equals X squared. We want it to go upside down. So we're going to reflect it across the X axis. So we're going to need to make it negative. We're going to shift it to the right 3. And we're going to go up 4. So negative, because why? Upside down, the flip. How do I shift it to the right 3? Minus, not plus, sorry. -3 inside the parentheses. Up 4. Okay. How are we doing?
If we would have flipped that over the y, what would that have been?
That's a good question. If you were to flip this over the y, then, and that's all you're doing?
No, it's only thing changing, like if it was still.
The problem with flip,
right 3 and up 4, it's flipped it over the y.
okay, I'm not trying to be devil's advocate here, but I could give you another example. Here's y equals X squared looks like this. If I flip this over the y, it's going to be the same thing. Does that make sense?
Oh, yeah.
So it's a bad, yeah, it's a bad example. But if I said y equals X to the 3rd, okay, we talk about that one, then if the, what it would look like is the new function would be y equals negative X to the 3rd.
That's over the y.
That's over the y, because the inside of the parentheses is going to be negative. This one's another over the y equals X squared plus 4X related to y equals negative X squared minus 4X, because they're exactly opposite of each other. That's what happens when it's flipped over the y. The whole thing is opposite. This one is it's gonna be the same whenever I make it opposite of each other. I don't know how to, because a negative X times negative X is still gonna give me X squared. That makes sense. Yeah, it's just not gonna work right. Good question though. Yes.
Is it possible for like a negative to be inside the parentheses, like in front of the X? Or do you write it on the outside of-
If you're reflecting it across the X axis or upside down, it's got to be on the outside. If you're reflecting it across the Y axis, it's on the inside. Yeah. Okay. I can stay and work. I have another class after this. I can stay and work more examples if you want me to. If you need to stop and talk to me about anything, any homework problem, I'll be more than happy to help you with anything?